Yeah.
Thank you so much.
It's kind of a hybrid seminar. We have some folks joining online and some in person here. So we'll try to moderate the questions that come out online. We have a faculty member here who will help us ask those questions, Dr. Didi.
Thank you.
Maybe we'll give it a minute before we start.
Okay.
A couple of this. Hey, welcome back to the Matrix AI seminar series. And I know Dr. Didi is also running his graduate AI practicum seminars and research seminars through here. So welcome all. Today we have a very special speaker joining us, Dr. Toufeeq Ahmed Syed. He was actually supposed to be joining us in person, but due to last minute scheduling conflicts, he is still able to give the talk virtually for us. So thank you, Toufeeq, for accommodating. So Dr. Syed is an associate professor and assistant dean of education informatics at the McWilliams School of Biomedical Informatics. And he's also the associate professor at the McGowan Medical School at the University of Texas Health Science Center at Houston. So he's not too far from us. The very recent position. Before joining UT Health in 2023, he was an assistant professor of biomedical informatics at Vanderbilt University School of Medicine. He has more than a decade of experience serving in informatics and AI leadership roles. He was Chief Technology Officer for an NSF-funded AI startup, Founding Director and Executive Director at Health IT at Vanderbilt University Medical Center, and Assistant Dean of Education Informatics for Vanderbilt University School of Medicine. And he has developed several innovative technologies, including VStar, QuizTime, Turnout, and Spark. So I think the accolades continue, but today he actively leads education informatics research and innovations and is active in national and international medical education technology and data standards committee. And more importantly, his lab is leading precision education in healthcare and mentoring networks research by developing innovative AI-based national and online platforms, especially for the Aim Ahead Connect, which he's going to talk to us today a lot about. And so that these kinds of networks can deliver personalized education, mentoring, career growth, and thereby enabling intervention-based research, and also increasing the nation's biomedical and AI workforce. So I had the pleasure of interacting with Toufeeq over the last 6 months, and he's always been a pleasure to work with just because of his knowledge both on the AI side as well as on the informatics side and the medicine field. So it's an honor to have him join us today, and we are really looking forward to your talk. The floor is yours, Toufeeq.
Thank you. Thank you so much for that warm welcome. I apologize for not being there in person. I look forward to the next opportunity I could be in San Antonio. Thank you all for joining. Feel free to stop and pause if you have any questions. I'll be happy to answer that. So I may have more slides than an hour, so I'll be happy to pause in between and take any questions. So let me jump in. Thank you so much for introduction. So I can skip some of these. I have a deep background in AI machine learning. I did a 2-year National Library of Medicine fellowship in biomedical informatics at Vanderbilt School of Medicine. I'm also very active in AAMC, which is Association of American Medical Colleges. So very active in medical education side. Let me start with one of the first projects that got me into biomedical sciences, but also has an educational aspect. So we have all used Google Scholar, or for those of us in biomedical sciences and life sciences, we use PubMed on a daily basis, which is based on a database NLM has been building and maintaining, indexing all the journals and published literature into one place called Medline. So I built an innovative search engine. This is almost in 2008 to 2010, where when you're reading, for example, if you're a microbiologist and you're looking into very specific virus or a specific gene or protein, you want to know everything about that topic. You want to know, for example, if you're starting a lab experiment that takes months to set up and do, and then you are writing a paper you're about to publish, then you realize somebody has done the same work in France 3 years ago. That would be not an optimal use of your time. So you want to be on the top of the field. Fortunately or unfortunately, in biomedical sciences, there are a lot of...
那你说非得哪天都一个人都不得。
Sorry.
那你说这，人家开店也是有点儿的，不是说开的店开。
If you could mute on your side, thank you. So we built a tool, an online platform called PubMed that indexes all the data, but we use natural language processing and machine learning to extract all the entities in an abstract or the journal. And this was way before ChatGPT. This was in 2008 to 2010, where if you are looking, for example, this project was highlighted at Arizona State University, where I graduated with a PhD. This is a search engine that sits on top of Medline database, right? And we're using AI, machine learning, especially natural language processing, to extract all the entities in a given abstract or journal and all the relationship that exists between those entities. So for example, if I start with cholesterol, I click on that link, I can quickly go from, for example, here I have almost 2 million articles, right, in my data set here. So 1,091,918,000 articles, right? I click on cholesterol, I get to 27,000 articles, right? I pick hepatic lipase, I pick hypothyroidism, just 3 clicks, I have 3 articles, right? So you can quickly narrow your focus on your literature search, and you can read these articles this afternoon, right? So this was the intention, to bring structured search, or what we call faceted search, based on machine learning. I was invited to speak at a TEDx Phoenix on this particular project. I was honored to give a TED Talk on this topic. This was 2010, where I was talking about AI machine learning and why we need tools using AI to help us with all the data, especially unstructured data we were creating. And we had to wait 12 years for ChatGPT since then. Since 2012, I have been deeply involved with education side. At that time, our school, our medical school, was going through a curricular transformation. Our dean asked me if I can help with building technology. So the idea was we moved to competency-based education. So this education, if those who are not familiar with the word competency-based education, it's similar to Montessori education. So you are learning things based on your current knowledge and your capabilities. For example, if you have a PhD in genetics and you go to MD program, in the first year, you're learning introduction to genetics, you may not need to attend that class, right? You already have that competency. So idea was to put entire curriculum into competencies, and those competencies are delivered through learning objectives. The learning objectives could be taught as activities, and then for those classroom activities, there could be self-directed activities, they could be in a clinical-based activities. And those activities, once you do that, you have assessment. We put all the data into common data warehouse. And then on top of that, we build what we call a personalized learner portfolio. So this is individual portfolio for each student based on the learning activities they've done, the assessment they've done, the evaluation they have collected, everything into one place. And based on all the data, we build what we call a personalized learning plan for that student. And we assign them, each student, with a course that will follow, that will mentor the student, is in this case, MD student, undergraduate medical education, for all 4 years. In order to facilitate all this, we also needed to build dashboards, administrative dashboards. We also had program evaluation that was geared towards competency-based assessment. So this was the idea, and our dean said, can we do this? So I said, first we have to see what technologies we have, and at that point, we didn't have much. So we decided that we need to build major components of education technology at Vanderbilt, and we needed updated course management system. That's the basic thing. but we also needed a competency-based assessment system. We needed a system to do personalized learning plan. We also wanted to do mobile data collection because our students were all over medical center and outside within a Nashville area where they were shadowing somebody or they're in the clinic. So they were in all multiple places. So we needed the data collection to go with them versus them coming back next day to input the data. And we needed basically like major overhaul of the technology entire systems. So I was the founding director of a new division we called Education Informatics. So before we could do AI machine learning, we needed to have proper platforms in place that'll collect the data, that'll provide a better user experience for learners and educators and course directors and program directors. So we looked at different vendors. At that point, we could not find one tool or one platform that does all or even multiple. So we decided we're going to do what called best of the breed approach. We said if there is a system that does it really good for that particular tile, we're gonna purchase license for that. If not, we're gonna build it and then we're gonna connect all that parts. For example, if you put input data in one system in one place, the data should flow so the user don't have to input the same data again and again. And all these tiles underneath, we built an educational data warehouse that all the data goes in one place. And then we can basically build our predictive modeling and everything on top of that data warehouse. So this was back in 2013. We released a new platform we called VStar for our medical education. And this was highlighted by both AAMC and American Medical Association, AMA, for its innovativeness. And we were able to get a major grant award from AMA at that point. So the idea was to build, so what does VStar do? So VStar, the overarching idea is to enable a learning healthcare system. So this is a great idea. In order to do that, we needed to have fundamental pieces in place, all connected, all integrated. So that's what VStar is. It's an integrated platform that has learning management, it has a student portfolio, it has curriculum search, curriculum mapping, it has grades, grading system integrated, it has a feedback, it has an outcomes database, all that into one system. So this is a quick snapshot of very early version. It has evolved a lot since then in last decade. Early version of a portfolio system, how it looks. It pulls information from the gradebook. It pulls information from different assessment systems, evaluation systems on this particular student. So all this data is coming from multiple systems all in one place, and then we can guide the student in a more meaningful way. We also started building a self-directed learning module. So this is we're looking at a framework called SMART framework. So when a student is creating learning goals or a mentor or coach is creating on her behalf, we want to follow what's called SMART framework, SMART. So each goal has to be specific, measurable, attainable, relevant to the student or the topic at hand, and time bound. So we build a system with that, with this framework in mind. This is an example of that. And we had different multiple competencies. So in each competency, student can identify their gaps, identify areas of improvement, and create learning goals that could be tracked by the student and also supervised by the coach. So I'm moving fast. Please excuse me if it's too fast. I can slow down and go into a specific slide. So here we are looking at our dashboard for a student on competency-based education. So you can see there are multiple competencies here. 6 highlighted: medical knowledge, patient care, all the way to system-based practice. Each dot represents the student assessment or evaluation at a given time. So here we have multiple kinds of student assessment. You can see self-assessment, faculty assessment, we have peer assessment. We also have what's called open assessment, means anybody, if they're in a clinic, a nurse can give a feedback, or even patient can give a feedback, or technician can give a feedback on the student, how the student did in that particular session. So all this data is in one place. So you can see this student at a given time has, so the competencies on the bottom is entry level, and on the top is ASPA, right? So this is a scale we have built through WMC. So there's multiple working groups who come together to build these competencies for medical education. So each of these dot indicates that student's assessment at that particular time. And what we want is by the students in first two years, we want them to slowly start here and then slowly go up in the competencies. So preferably at 4 or 5. So you can see some transition happening, the progression happening here for this particular student. The other thing we did was, because we had all the data for all the students in their cohort, you can click on a dot as a student, you can quickly see where am I compared to rest of my class. So I have 99 students in the cohort. You can see I'm at 2, a lot of students at 3, some are at 4. So you can quickly see yourself where you are. And so this is very helpful for a coach to say, okay, looks like you're a little bit behind the class. You know, you need to do these activities, you need to create these goals to catch up. So the idea is to help students go from 1 or 2 to 3 and 4, hopefully 5 by the end of the year. Similarly, for each cohort, we can see the progression for the entire class as they go through first semester to mid-clerkship to end of clerkship, right? The data is coming from different places, so we can quickly, so all these dashboards are very dynamic. So if somebody puts in some more assessment today, this will be all refreshed. So let me pause here. I'm switching to another project we call Compass. Compass is a mobile app. So this is a mobile data collection process. So the student could be anywhere in the clinic. They work with a particular attending or say an anesthesiologist or they were internal medicine or the peds. So they can ask feedback from the people who were around this particular student. A lot of times we don't know who they work with while they are in the clinics or in their clerkship years. So the idea was the student will identify a person if they are at the institution, say Vanderbilt. They know the search the last name, so Dr. Smith, they find and they click on the button to request feedback. Dr. Smith will get an email or text message. They can click on the link and type the feedback or actually dictate the feedback on the phone. And then all that will go into the student portfolio. So this was highlighted by WMC. We won one of the presentation awards in the annual conference for this mobile app. So another app we have built called Quiz Time. I'm very proud of our team who developed this. So idea of Quiz Time is to bring inquiry-based learning or just-in-time learning in between didactic sessions. So you have, say, class on Monday, Wednesday, and Friday. As an instructor, course director, you want to keep your students and learners engaged in between those sessions, right? Similarly, in continuing medical education, so all the physicians, like, for example, all professionals, like, so nurses, they have to have continuing medical education credits. So nurses have continuing nursing education credits and so on. So typically a physician attending needs to have about 48 to 52 credits for their discipline to keep up with their accreditation. So each year they have to acquire those credits. So one way we thought we could actually make this easier. So typically one credit is given if you attend a seminar like this one, right? If it is a CME accredited activity. So we said, what if we turn that into a more just-in-time learning? So idea of Quiz Time is, as a learner, you sign up for a course and you with your cell phone, or you can do an email too. And every day at a specific time of your choosing or the instructor's choosing, you get a question. So you read the question. It could have an X-ray image in it. It could have a CT scan. It could have a video. It could have a case. You answer, and right away you get whether you got it correct or incorrect. If you get it correct, you get some more explanation, some more resources to add to your existing knowledge. If you get it incorrect, you get a lot more detailed explanation. And if it is an on-demand course, that incorrect question gets added into your queue. So we do what's called spaced repetition. So we use a machine learning algorithm to personalize that for each learner. So if you get it correct next time, that question will come back much later. If you get it incorrect second time, it'll come back again sooner. So this way, it helps with memorization. So this is all based on almost 100-year-old theory by Ebbinghaus. So there's a forgetting curve. So you forget if you don't repeat things often, right? It's actually very useful if you're memorizing for SAT or board or other MCAT or other exams like that. So on the instructor side, or the course director side, we made it very easy. So as soon as a daily questions happen, the questions go out to students, they answer the question, the instructor will get a text message at the end of the question. So you give them 2 hours to answer the question. At the end of 2 hours, you get a text message with the detail of how many opened, how many completed, how many got correct, how many got incorrect. So this way you can help not just understand the student assessment, but also whether the question is performing well. For example, everybody selected answer B, and correct answer is answer B, then the A and C and D distractors are not good enough. You may want to rewrite those so that students actually think about what the correct answer is. So we have rolled this out, especially in continuing medical education at Vanderbilt over the last few years. Was mentioned in different publications. We have written about this app. We were reached by the Tennessee Department of Health reached out and said, hey, can we do opioid prescription education through this, which is a huge issue. I think Tennessee, across the country, about the overuse of opioids. And so one of the insight was to help physicians do less prescription of opioids and find alternate therapies. So we built a course with QuizTime, and we rolled it out and across Tennessee, Middle Tennessee. So we had folks from Kentucky, as you can see on the map here, and the Southeast. We had about 3,000 participants that included MDs, pharmacists, nurse practitioners, and so on. And we, through this pilot program, we awarded more than 13,000 CME credits. So this way we scaled it up. So on the operational side, we had originally built this app, the platform, to be used internally to Vanderbilt, right? And then we were approached by Tennessee Department of Health, and we had about 3-4 weeks to build this and scale it to thousands of learners, like a massive online course. And we did that by put everything on the Azure platform. We scaled it up, and it worked great. So this was also highlighted in multiple places, including our annual State of the Medical Center address, local channel covered as.
Toufeeq, there's a question.
Please. What is the core medical data information that the system is pulling from? Seems like it would have a massive data set. That's a great question. So let me address that. Thank you for this question. So like say, undergraduate education or master's program and PhD program, we collect a lot of data on our students, especially in MD education. There are multiple learning activities that are going on for the students. So we have typical Blackboard Canvas like a system, right, where we deliver our courses. We also have a system called ExamSoft for for assessment. We have Qualtrics for evaluation. We also have their application data, where they're coming from, where their previous grades, previous courses they have taken, and all that information, including demographic information and so on. We also have, when they're going in clinics, when they're doing clerkships, we have data on what patients they're seeing. We can connect to the Epic if they have access to the EHR system. Sometimes there's a training EHR, so we have access to that. More importantly, if you start thinking about like how Amazon or Google collects data on users, right? Not just learners. So learners, we're looking at whether they got a grade A or B. But if you start thinking all the data we actually have, for example, how often they log into Canvas, do they watch all the videos? What speed they watch the video at? Did they take, for example, did they change the answer from B to C and C to B multiple times before they finally selected D? So we have all that information, all the clicks. And usually we don't store that information, right? But if you want to store that information, you can do a whole lot more in terms of how we personalize education for our learners. So we do collect a whole lot of data. A lot of times it's not visible or it's not stored. Like, we keep it for operational purpose for a day or two, and then we delete those logs, right? But if you have a data warehouse and if you have a purpose, you want to build an outcomes dashboard, database or dashboard, you can start to extract that information in a meaningful way and come up with some interventions. For example, this is anecdotal. We had one student that complained about time management, and it's very important in graduate school, equally important in medical education. And we had multiple times that student was complaining, the student was having difficulty managing time with all the competing priorities and courses and so on. On one hand, the student was, this being Nashville, was doing an opening gig for a local country music band. And those two don't go together. I mean, we don't capture that kind of information. And then if the coach has that information available, saying that, hey, it looks like every day or multiple times a day, you're not available from this time to this time, and you're doing something else. And on the other hand, you're saying you don't have time. So in terms of providing this is the core idea of precision education, where we are personalizing education experience for students, just like Amazon personalizes your shopping experience. I hope I answered the question.
There is one more question from Mark.
So my question has to do with culture, which is, as a medical educator, I think we all know that students, especially medical students, have come to be much more interested in grades than they are in evaluation. And that pervades not just their experience, but also what they're looking for from evaluators. And they're not happy oftentimes when the grades are reveal the true extent of their knowledge. So that requires, in order to get good data, which drives your whole system, you have to have better evaluation. I'm wondering, that's a culture change. That's not a technology change. How do you do that?
That's a great question. So a lot of our course directors and faculty had already bought in the idea of curriculum 2.0. So we said we are switching to competency-based education, where we are, and the students also have to be bought in when they're applying. They knew that the system at Vanderbilt is different. Again, some of the examples I've given here are we didn't apply to across entire Vanderbilt per se. Like we have done some, internal projects and so on. So I'm highlighting that. So it definitely needs a culture change. It needs, again, there's a question about privacy. So there has to be buy-in. But here I'm presenting what is possible given the data we have. And every institution is different. Every institution's culture is different. Of course, you have to be transparent with the learners that this data will be used for these purposes, and we use this data not for these purposes, right? So that's very, very clear. But again, if you look at the education, sometimes I feel like we are a little bit lagging behind compared to what some of the e-commerce companies can do with our data, and then so on. So why not bring those, right? Again, we are not undermining the privacy of the student. I mean, there is a far part required, right? There's regulations that we have to be in compliance with, and so on.
There's one more question from Rohit.
From Corbin.
Please go ahead. I see two questions. There's one: how does system develop or draw on information about treating XYZ and symptoms patient comes down? So we are not focused on the clinical decision support. So my focus is, if I can draw a Venn diagram, we have healthcare, of course, and then we have education, and within healthcare, and then there's AI machine learning. So using AI machine learning, and especially innovative technologies to help with education in healthcare, not the patient side of it. I hope that makes sense.
There is a question from Corbin about privacy.
Yeah, I mean, again, what I'm presenting is different projects I have done in last decade or so. In each of the projects, we had the buy-in from the leadership, the buy-in from the students. In most of the projects, we have also included students. We have set up a student technology committee that was fairly active in making decisions about the data. We brought transparency to the student what the data would be used for. If this is just a project, we tell them this is just a project, like in the case of Compass, or if this is used for promotion purpose, we'll tell them this was upfront that this data is collected and be used for promotion purpose. Because in medical education, the students are very, like other graduate programs, are very sensitive to grades and what evaluation is given on their behalf and so on. So this is important. So let me switch to natural language processing. You may be very aware of this, especially the recent technology innovations in this space, ChatGPT and OpenAI and so on. This has been a fairly active field for last 20+ years. We are seeing great innovations in last 4 or 5 years because of the artificial neural networks, or what we call deep learning algorithms and a vast amount of data we have. So how does it apply to medical education? For example, the same word in curriculum could be mentioned in multiple ways, right? Say we're talking about myocardial infarction, and somebody might just say MI, or somebody might call it heart attack. They're all one concept. So our goal here was, for example, type 2 diabetes could be mentioned in n number of ways, right? So what we have built was, this is the core technology we were building that could be used for curriculum search, and I'll showcase some examples of how we use this. So the idea was to build an NLP engine that'll take the document, that'll take as an input document. It could be PowerPoint, PDFs, HTML, and so on, and annotate them with the concepts. So as you can see an example here, and we wanted to try something different. Like in past, I had built NLP engines that were great, but they are usually slow, and they were based on Java and so on. So the other thing we wanted to do was keep it, use an ontology that is regularly updated, and we have access to articles about that particular concept. So we said, let's connect this to Wikipedia. And a lot of schools don't like the idea of referring to Wikipedia. We said, okay, for this project, let's try. Let's see what happens. So we used Wikipedia concepts. We also used an ontology called SnowMedCT. And we built a really fast Python-based service. We built this on cloud, and we had multiple parallel processes that will start. So as soon as you see a document, we break the document into multiple sentences. We send it to like 20 different parallel processes, and then we put all that together back into the document with the concepts annotated. So this way, we were able to get a really fast NLP processor. We called it Quick Match. As you can see, if the student, while she's reading an article, as soon as she clicks on the article, we send it to NLP engine. Within milliseconds, we will get the entire article annotated. And you can click on the link, and you can, it's annotated to connect to Wikipedia or First Aid or UpToDate or other different sources that we have indexed. So we can also find related concepts. I'll explain this in a second how we did that. So this way, when we extract all the concepts, we also build this into what we call a knowledge graph. And so this way, so you're looking at MI, you can quickly identify all the concepts that are taught within the curriculum. So we're not looking at the entire Wikipedia here. Like within the curriculum documents we uploaded, what are all the concepts that are connected to this particular concept. So if the student can click on any one of them, have access to the documents, the PDF or the PowerPoint. So we also wanted this NLP engine to be comparable to other NLP engines that are out there, especially CTX, Apache CTX. So the difference was we wanted Quick Match to be way faster, so it's on the fly. Like as soon as the student clicks on the article, we send it, we index it. So this way we're not pre-indexing things. So as you can see, we were able to get a multi-fold speed increase here compared to Wikipedia and CTX. We were able to do index at 140 times faster than that. So here on one side, we have how many documents Quick Match can crunch within a minute, about like 30,000 documents or so. On the right-hand side, we saw like, for the data set of 10,000 documents, how fast Quick Match would do, and it would do it less than a minute. So why is this important, right? So if you're teaching course, and every year you have some changes to the curriculum, and then you want to compare your curriculum with another institution. So about 8-9 years ago, WMC started Curriculum Inventory Portal, where you upload all the metadata on your curriculum and links to those documents. So imagine you have the entire curriculum for MD program, 4 years, say 40, 50 plus courses, and they have another school and 40, 50 plus courses. You can quickly compare and benchmark over all the topics and so on. And I'm giving an example of how it look like. For example, you may have seen in the ad, like how T-Mobile or another vendor is better than vendor A is better than vendor B because they have better coverage, right? But this way, same way, you can do curriculum coverage on a particular topic or overall on a particular discipline within like a few minutes. This is example using that NLP engine. We were able to build a semantic search engine for our medical students. So let me pause here. I will switch to mentoring connections. project. Any questions on the curriculum NLP? Yeah, thank you. So I'm switching to NIH-funded project. So this is everything so far we had presented was institutional based, especially at Vanderbilt. So National Research Mentoring Network is an NIH-funded national project. Our goal here is to provide researchers across all career stages in biomedical, behavioral, and life sciences, social sciences with mentorship and professional development. The idea is to increase diversity and increase biomedical capacity for the nation. So we are called National Research Mentoring Network. I urge everyone on the call to please look it up and join our network. What do we do here is based on the best practices from, this is National Academy of Sciences report on effective mentoring. Mentoring can happen in multiple ways. It could be that, mentor and mentee are connected, or it could be a network of mentors. So we believe that, you need more than one mentor to further your career or your research, create collaborations and so on. So with National Research Mentoring Network, we enable a mentee or a mentor to create their research mentoring network, to create their personal network of mentors for their career advancement. And the research has shown that the mentoring is crucial for not just advancement for individual, but also growing biomedical sciences pipeline from undergraduate to graduate students, from graduate student to postdoc, postdoc to research scientist or a faculty, or faculty to a junior faculty or an NIH-funded faculty. So this entire pipeline is really important, really crucial to have mentors along the way that help you get to the next stage. We have developed an online platform called MyNRMN, a National Research Mentoring Network. It's a free platform. Anybody can join. We have about 27,000 mentors and mentees across the nation who have joined this platform. All 50 states and US territories, we have more than 7,000 mentors. So you have access to mentors. For example, if you're looking for a mentor on a particular protein, P53, you can search for that and you'll find mentors on that particular topic. So I have built a NLP-based search engine behind that. So if somebody has uploaded a CV and on page 20th of the CV, they wrote a publication that mentioned P53, we can help you find a mentor for that specific topic based on that. So it's very easy to create that search. We have more than 14,000 mentees who've joined. We've made more than 11,000 connections from more than 3,000 institutions. So it's a national network. I urge everyone to leverage this. You can find great mentors, you can find mentees, you can find peer mentors. And we have, this is a geographical distribution of where our mentors and mentees are coming from. As you can see, we have representation from all 50 states and Puerto Rico and Guam and so on. So underneath this, so you are creating connections, right? You're connected to your mentor, your mentor is connected to another person, another mentee or so on. So this is a network, right? So underneath, we have built what's called a graph database, and we use machine learning techniques to help you find more connections. So you may have seen examples like if you buy 4 items on Amazon, Amazon will recommend 2 more items to buy. So Amazon does that. The 10 years, 15 years ago, they used to do what's called collaborative filtering. Since then, they haven't published much on how they do that currently. Maybe they're using more deep learning approaches now. But the idea was help you find more connections, right? Help you find more products there, or help you find more items, right? Or books. Similarly here, we used your current subnetwork. Let's say you're connected to 3 people. We use who they're connected to and what their About Me section is, what their CVs are, what the concepts they are expert in. And then we help you increase your network by recommending you more people to connect. So we use what was called social network analysis. I won't go into the details of this. You all know why it is important. Having a bigger network gives you access to more resources, more information. You have a more social capital, right? This is an example of a weaker social network. This person is connected to, coming from different institutions and so on. So everything within MyNRMN, we put that into graph database. Here's an example of somebody who has a strong social network. So hopefully there's more flow of information, more flow of resources and so on. So this is important. We help you build a stronger social network. In NRMN case, we help you build a strong personal network of mentors who can help you with your career and your research. So this is, I can go into details of what we do here in terms of machine learning, graph-based machine learning. Let me switch to some of the outcomes, why this is important, why creating mentoring platform has helped increase the diversity, right? So we're looking here at a Sankey diagram. On the left-hand side, we see mentees. On the right-hand side, we see mentors. So we had, in this study, we have about 3,000 connections between mentees and mentors. As you can see, on the mentee side, we have very diverse enrollment of mentees who could be undergraduate student, graduate students, or postdoc. On the right-hand side, we have mentors. And you can see our diversity in our faculty it's not same as the diversity in our student population, right? So you can see the connections happening. So one thing I read from this one is we have diverse connections happening. That we have students who identify as Black are connected to mentors who are white, Black, Asian, and so on, right? Similarly, students are identified white. So this is a diversity of connections happening, and it validates that you need a mentoring connections to help mentoring network to help create this diversity across. And one thing about NRMN is it's not just based on one institution. So you are connecting with mentors and faculty from across the country from different institutions. So I'll show a slide on that connection diversity too. So here we're looking at, this is based on gender. On the left-hand side, we have mentees gender, and the right-hand side, mentors gender. You can see we have a lot more females. It's as NIH has recently updated the policy to include females as one of the minorities in STEM. So this is right on in our chart. This one is mentee-mentor connections by ethnicity. So you can see Hispanic, Latino, non-Latino, and others, and connections happening with the mentors. This is mentee-mentee connections, peer mentoring, that's connected to undergraduate student, graduate student, and postdoc and so on, connected to other with the same level or higher level. This is interesting. We looked at minority serving institutions, our mentees coming from minority serving institutions, and how they connected to mentors from either MSI or Carnegie R1, Carnegie R2, and so on. So as you can see, we have students connecting from an HBCU to a faculty member at Carnegie R1 or R2, and I know vice versa. So usually mentoring is very localized, right? Mentoring usually happens within a department or institution because that's the program level support we provide. So here we are connecting to students. Somebody could be in Augusta University connected to Cornell University for their mentorship, and we're hoping that will help create a bigger network of mentors, more social capital. Hence, maybe that student will start a master's program there and then go for PhD program at different institution, or have a postdoc connection to a different institution. So this is a full-fledged platform. We have multiple features, including groups. We have search, we have mentoring programs. You can upload your CV, you can create your resume. If you don't have a resume, we have different templates. We have an interactive resume builder. We have Ask a Mentor question answering forum. We have a deep search, I mentioned that earlier. This is an example of question answering systems. You can post a question, and based on what you mentioned in the question, we send that to different mentors. This is all automatic using NLP. So if you, for example, if you're looking for P53 or you're looking for somebody in microbiology, we can identify mentors who are expert in that domain, and we send them an email saying that so-and-so has posted a question. Will you help this mentee answer by answering this question? We have different groups. Groups could be, we also have video chat built in the system. So you can do both one-on-one mentoring, we can do group mentoring. We recently released a job board. So if you have any jobs that or program level outreach you want to do, please reach out to us. We'll be happy to post this on our network. This way you can hire from a diverse pool of mentees and students. These are some of the metrics on the dashboard. We recently built a free online course on unconscious bias. We had more than 4,000 students, learners register for this, including some of the deans and the school administrators. So we had like about 50–60% completion rate. And at the end of the course, it's a 5-module course. It will take about 3 to 5 hours total. And it's an asynchronous course, like a MOOC, and you get a completion certificate with NRMN banding once you finish this course. And we also have a feature where if you have faculty or postdoc or graduate students, you want to bring them and as a cohort for this particular course, we'll be happy to set that up. It's very easy. You can bring in 500 people from your institution. We can they can all take this course, and you get the data on their completions and so on. Let me switch to another project. This is also in terms of this is a large project. This is a new project we started about 2 years ago called Aim Ahead. The goal here is to build a national consortium to increase participation and engagement from minority communities, underserved communities in AI machine learning. So as a part of Aim Ahead Coordinating Center, we are given charge to do planning, assessment, and capacity building. We have we're in the second year cycle. We just had our year 2 call for proposal and programmatic review and scientific review done. We're halfway through announcing all the awardees. We're still waiting on two or three programs to award to release the notice of awards. So in year 2, we had 6 programs that included research fellowship, leadership fellowship, multiple different awards from minority swing institutions, from capacity building to building an AI machine learning lab to a large project, what we call consortium development project. So I'd be happy to discuss this in a separate call. Feel free to reach out to me if you're interested in Aim Ahead funding and Aim Ahead opportunities to join this consortium. So quick brief overview of the consortium. We are organized as 4 cores. I'm part of leadership core. I'm one of the PIs and PIs of these of the Aim Ahead consortium. We have infrastructure core, we have data science training core, we have data and research core. So why should somebody join Aim Ahead as an individual researcher or as an institution? The reason is, apart from funding opportunities, we also have infrastructure for you to do AI machine learning, modeling and validation testing. Basically, we'll give you actual computing infrastructure. We have Workbench, we have multiple partners who will provide infrastructure that includes both cloud-based hardware or local IT institution we can help you install. We also have data sets. We have multiple data sources, data providers, including data from EHR, including image data, and so on. So based on the project and your need, it will help you find the data. We already have 3-4 data sources, large data sources, including Ocean MedStar, which is a large medical system in DC area. We have data sets from other partners, Temple University, and so on. And then we have also data science training core. The data science training core is building online courses. I'll show that in a second. And also they're providing training opportunities in AI machine learning. So this is a great place to not just learn about AI machine learning. You get access to data sets, you get access to infrastructure, and we also have funding opportunities for the projects you're interested in doing. So I have built, so this is a quick look into the North Stars. So the goals of Aim Ahead is to increase diversity and build an inclusive AI machine learning workforce. Of course, increase the knowledge and awareness of AI machine learning, what it can do, and also the biases that it can bring into the community, build capacity and infrastructure at minority serving institutions and under-resourced communities, and use AI machine learning to reduce health disparities. That's a major aspect of Aim Ahead. So I have built a platform for Aim Ahead similar to NRMN. We call it Aim Ahead Connect. So please join this platform. You'll have access to data sets, you'll have access to courses, you'll have access to funding opportunity announcements, you will have access to connect with AI machine learning, health equity, health disparities, researchers across the country. So here is a quick, we're still working on bringing all the data sets Aim Ahead has collected so far, but this is a quick release of our feature we call data sets. So these are training data sets. These are available right now. We have partnered with University of California, Irvine to bring these data sets. And we also have other data sources. We'll be adding more data sets to this repository. This shows different courses we have made available. We have 2 kinds of training opportunities. We have online courses, on-demand courses. I'm showing a catalog of our online courses. We are going to be adding another 5-6 courses within a month to this catalog. We also have in parallel workshop-based, hands-on training opportunities that are coming up. We have partnered with All of Us Project. We have partnered with NCATS. So they're bringing in multiple vendors who will provide these training opportunities. So keep an eye on amahet.net. We'll post those opportunities. These are paid stipend. The stipend is available for each of these opportunities. These are immersive, hands-on training opportunities for graduate students, postdocs, and junior faculty. This is quick information on different features in Connect. Connect is also helpful, not just to connect with the mentors and mentees, but also, as mentioned, different aspects. In order to build a consortium ecosystem for AI machine learning, I'm imagining a 4-quadrant system where we have connections, networking, mentoring, groups, and so on. And then we have data sets, we have courses, and then we have infrastructure like Workbench, notebooks, Jupyter notebooks, and so on. So hopefully by end of next 6 to 8 months, we'll have all 4 quadrants. Right now we have 3 of them. We are working on the 4th, where we are bringing notebooks and infrastructure. Is part of the infrastructure for Jupyter notebooks or Workbench that can support R and other tools. We launched this about a year ago. We have almost 3,000 users on our platform. These are experts in AI machine learning, or these are experts in health equity, health disparities. We have multiple organizations who are our stakeholders. This is from year 1. Once the year 2 awardees are announced, we'll update this slide deck. We'll have more than 100 awards going out in the next few weeks. So let me pause here. Any questions on Aim Ahead or NRMN?
There is a question from Mark.
Yeah, thank you. So what drives participation by faculty experts who are very busy at their own institution? This is a great question. So how we recruit? We usually recruit from events like this, like the webinars, and we hold multiple webinars. We also recruit faculty and mentors at national conferences like ABRACAM, SACNAS, and ACES, and so on. Just like why would somebody mentor at their institution, the same I think thought applies at a national level too. At a national level, we are recruiting mentors who are focused on increasing diversity, increasing biomedical pipeline, and mentoring is like, as you understand, it's a way to give back. Like, I am here because of my mentors, right? And it's the same thing, like, the same thought applies. Like the mentoring can happen at the institution level, can also happen at a national level. A lot of times, if somebody is at Idaho, small school in Idaho, they may not find somebody like them as a mentor, but on our platform, they can find somebody like them at a different school, maybe all the way in West Virginia or so, right? So that is very powerful. So you can see the different aspects to mentoring, and one of them is identity, right? Who you identify as, and if you have a role model that looks like you, that is very powerful. So that's what we're trying to do. Again, that's not the only thing we're trying to do, but that's one of the things we're trying to do. Where as a mentor, this is appealing to me because I can mentor folks who don't have access to mentors at their institution, or sometimes if you're in a 4-year degree program and you want to go do PhD, sometimes if you connect to a PhD program and connect to faculty there, you get a lot more information and you get more excited about you're more likely to apply to a PhD program. So that's the core idea of that. And we had, it's easier for us to recruit mentors. As you can see, every year we easily meet our mentor recruitment goals. Typically, last 2 years since pandemic, we're having slight difficulty in mentee recruiting because they have a lot more tools and if I can say, a lot more distractions. But mentor recruitment has not been difficult for us. Sorry, long answer. I hope I answered it.
Yes, it does. Thank you.
There's a question from Keith.
Yes, I want to ask a question about the previous ALP project for the course curriculum. Can you give a few more examples how such system, especially focused, if I understand correctly, about semantic or concept mapping can be used on student side and the instructor side and maybe other stakeholders in the education system.
Okay, so I had shown two examples. So we built it in two parts. We built an NLP engine that could be used for multiple things. And one of the things we used, it's like students are in Canvas or Blackboard or an LMS, they are reading content, right? And while they're reading content, they find a new word they don't know. Of course, they can put that in Google and search, and they get like 20 results or 2,000 results, but they may not be reading from a very specific source, as a course director you want, right? So with NLP, you can say, okay, I want to extract all the concept from a PowerPoint, but I only want to use this particular source. So we can do that quick matching. This way, students have access to the course content, but also reference material that are approved by the faculty member. Right, that's one use case. There are multiple use cases. Once we have the core technology built in, we can come up with multiple use cases.
Okay. Thank you. That's very interesting.
Topic in terms of the infrastructure AIM ahead, apart from the computing infrastructure, what do you have in terms of biological infrastructure?
So we have multiple large data source providers, including EHR data, including imaging data, including social determinants of health. So I'd be happy to connect this offline. We have a whole data and research core that is funded to provide data sets. So if you have a project idea and you don't have the data sets, we'd be happy to work with you to help to get you those data sets if possible. The other one is the actual computing infrastructure. Once you join the consortium, you will have access to Workbench that you can run your Python code, R code, or other machine learning algorithms. We provide that free computing, free infrastructure. And we also have training sessions. We have online courses. We'll have immersive training coming up soon within a month.
I had a question about your environment model. I know it provides an opportunity for mentees at multiple institutes to connect with mentors across the nation. Were you able to track over a period of time? Do you have any kind of temporal data that gives a guidance on how successful the mentee-mentor relationships have been over a period of time? I mean, sometimes like if you have too many mentors, I mean, what is that kind of threshold? Did you have any statistics on that?
That's a great point. We are currently doing a study on that. We're collecting data on that. The role of mentors, specific mentors, and the network of mentors. We have 2 manuscripts currently. Again, we have collected a lot of data. It takes time to analyze and write manuscript and so on. So we're a little bit behind that. So we have 2 manuscripts in place that kind of shows the value of the data that we're collecting. One is we call transition points. So the transition points, as I defined, is somebody goes from master's to PhD or undergraduate to master's to PhD, PhD to postdoc, and so on. At that point, it's really crucial that they actually make the transition. So we are, as a part of our platform, if somebody changes their profile information, we keep the log history of that, like they change the email to another institution, they change their address location. So we identify, okay, this was a positive transition. They went from undergraduate to master's program. Like changing the zip code doesn't mean they actually changed the institution, right? But if they change the institution name, they change the program, multiple fields can define a positive transition. And what we have seen in our study, we had about 7,000 of these positive transitions in last year and a half. And we saw that those who are more engaged, have a bigger network, are more likely to make the positive transition than those who are not active.
Any questions?
Go ahead, please.
I think there are no other questions, Toufeeq.
Okay, so let me tie this all together. I'll just have one or two more slides. So how does it all work together? So every year, this is an example. This is a Vanderbilt graduation As you can see, we are like 4,000 or 5,000 students in there. So for each student, we collect a lot of data, right? So once we start thinking at a scale, can we personalize each learner's education experience? So idea is we already use a lot of tools that are very customized to us. Simplest is the GPS, right? It knows where you are, you punch in where you want to go. It gives you multiple paths based on whether you want highways or not, whether you want shortest path, whether you want to conserve gas, multiple different constraints you can put in there, and it gives you a path. And if you divert a little bit, it changes that, it adapts to your location where you are, right? The similar idea for our learners, the goal is to increase retention. Goal is to get them to where they want to go. Some already have attained those competencies. They already know that content, right? So idea is, can we build tools using AI machine learning that are personalized to each learner, not just a cohort of learner or a discipline, but each learner at different levels of personalization. So that's what we call precision education. So the term is borrowed from precision health. Just like precision health, we have lots of data on a patient at a gene level. As a student, we have access to data at every click they do. And there are multiple ways to personalize and help a student, all the way from their performance and their career to, on this end, to their well-being and their mental health and their stress level and so on. So that's where my research intersection is. I'd be very happy to collaborate. If you have any ideas, if you have a project, please feel free to reach out to me. So I'm very interested in this space, and I also thank everyone on this call for the great questions, and I hope I was able to answer. If not, please feel free to reach out to me. I'd be very happy to connect, especially if you have any questions related to Ahmed or NRMN or education informatics or applying AI machine learning to education. I'm always there. Thank you. Thank you for your time.
Any more questions? No questions. Thank you so much, Toufeeq, for gracing us with this wonderful talk. We are really motivated with the way you are doing collaborative learning and NLP-based education that really propelled us. And specifically the AI-based consortium, we are really looking forward to connect with you towards impactful contribution in the future. Thank you so much.
Thank you.
Have a beautiful weekend.
Thank you. Thank you all. Have a wonderful weekend.
Thank you. Hey, we can see you for the first time.